is Adeyemi Oluwadimilade Deborah, the creator of Compass 0.0, and this video is the part 2 in a Longitude and Latitude series, and here we're going to learn everything on calculations on longitude. Longitude is the measurement of a location east or west of the Greenwich meridian or prime meridian. They are imaginary lines running from north to south of the Earth's surface. If you've watched our video on calculations on latitude, then you might think the definitions are similar, but if you pay close attention, you'll see the differences. First, let's define the keyword in our definition, which is Greenwich meridian or prime meridian. This is an imaginary line that divides the Earth into equal halves, similar to the equator. But while the equator divides the Earth horizontally into northern and southern hemispheres, the Greenwich meridian divides the Earth vertically into eastern and western hemispheres. So back to our earlier definition, longitude is the measurement of a location east or west of the Greenwich meridian or prime meridian. Lines of longitude are also called meridians. So even though the longitudes tell the location of a place east or west of the equator, they run from north to south. Functions of lines of latitude. Number 1, they are used to calculate local time between two places on the Earth's surface. The calculations in longitude are based on these facts that are used to tell the time between two places, and a lot of questions come from longitude in comparison to latitude. Number 2, latitude and longitude lines work together to provide precise geographical positioning on atlas maps. Both latitude and longitude coordinates intersect to define exact locations on maps. In the last video on calculations of latitude, I gave you the position of Nigeria. Now let's identify another country. South Africa is located between latitude 23 degrees to 35 degrees south and longitude 17 degrees to 33 degrees east. Now let's look at some terminologies on longitudes or meridians. Number 1, Greenwich meridian. We've already defined this earlier. Simply, it is the 0-degree longitude line. The international date line is an imaginary line located at approximately 180 degrees longitude. It serves as the line where the day changes by 1 day. Crossing it westward makes you to lose a day, and crossing it eastward makes you to gain a day. It is not straight, as it zigzags to avoid splitting countries or islands into different days. The reason why I said approximately 180 degrees is because the line is zigzag, as we can see in the definition. You can check online for pictures of the ideal. If it was straight, it would cause some countries and islands to be split into two different days. This would cause confusion and problems for communication, business, travel, and daily life. For example, imagine an island or country with two parts, east and west. If the ideal were straight, it would look like this. The east part would be a day ahead of the west part, and this would be confusing. Hence, the line will have to curve around the island, giving it a zigzag appearance, like so. Now let's talk about great circles. A great circle is the largest possible circle that can be drawn on a sphere. And great circles also represent the shortest distance between 2 points on a sphere. That is why most airplanes and ships follow great circle routes for efficiency. Now let's look at examples of great circles. The first one, lines of longitude. Any pair of opposite lines of longitude, e.g. longitude 0 degrees and longitude 180 degrees, forms a great circle because they connect the North Pole and the South Pole and pass through the Earth's center. And the equator is the only line of latitude that is a great circle. Remember, I made reference to it. Since a great circle divides the Earth into two equal halves, we also mentioned in the latitude video that the equator does that. So the equator can also be considered as a great circle, along with opposite lines of longitude. Now, a small circle is any circle on the surface of a sphere that does not pass through the sphere center, and they don't divide the sphere into two equal halves. If the equator is the only line of latitude that is a great circle, then that automatically makes other lines of latitude small circles, since they don't divide the Earth equally into two halves. I know this seems like a lot to take in, but you need to understand the difference and also the characteristics of both great circles and small circles, as they can be asked in theory. But looking at diagrams I'm about to show you will make the concept clearer. Now, this is what I meant to say by great circles and small circles. As you can see how the largest circle divides the Earth into equal halves, but the small circles won't do that. This diagram looks similar to the picture I showed on key lines of latitudes. So now let's try to identify which lines are present. I hope you got the lines right as well as their positions, and I hope you didn't switch the positions of Cancer and Capricorn. So the line at the center, that's the great circle, the equator, the only line of latitude that is a great circle, divides the Earth into two equal halves, northern and southern hemispheres. While as you can see, the Tropic of Cancer and Tropic of Capricorn, even if they cut the Earth, is not going to be into equal halves. Since we looked at the latitudes, now let's look at longitudes as earlier mentioned. All lines of longitude, when paired with their opposite longitudes, form a great circle. So therefore, a single line of longitude will only be half of a great circle, since we need two pairs of longitudes to form a great circle. Looking at our picture above, the longitude in front of us is longitude 0 degrees, which is also known as the Greenwich meridian. This line alone makes only half of a great circle, but if we take its opposite longitude, which is longitude 180 degrees, also known as the international dateline, we have a complete great circle. So now hopefully you understand the concept. So make sure to take note of these terminologies, as we'll soon see in theory questions their relevance. Now before we move on to calculations, let's look at this scenario. Longitude and time differences. Now you are in Lagos, Nigeria, enjoying a quiet evening with your family. As you glance at the clock on the wall, you see that at 6 p.m. Suddenly you remember that you need to call your cousin Favor, who recently moved to New York City. You pick up the phone, but before dialing, you pause. Favor once mentioned how annoyed she gets when people forget the time difference and call her too early or too late. Not wanting to upset her, you try to figure out what time it is in New York. So now let's move on to calculations, and I'm sure by the time we're done, you understand the concept behind this case scenario. So just like we had principles for calculating latitude as we saw in our last video, we also have for longitude. The principles follow a similar pattern, but one of the biggest differences is that for longitude, we are dealing with east and west and not north and south. Just like before, if the two places are on the same hemisphere, for instance, if both of the places are located in the east, then we subtract their longitudes. But if they are in different hemispheres, that is one place located in the east while the other is located in the west, then we add their latitudes together. By the side, I'm sure you must be wondering why east means addition and west means subtraction. But if you remember when I was explaining the international dateline, I said that when you cross it westward, you lose a day, and if you cross the ideal eastward, you gain a day. This also has application in time as well as days. You'll understand better when we start solving questions. What units can be used to measure time? It could be days, hours, seconds, minutes. So we will need to convert degrees to any of these units. And to do that, we have three equations you must never forget. 360 degrees equals 24 hours, 15 degrees equals to 1 hour, and 1 degree is equals to 4 minutes. Firstly, we need to remember that the Earth makes one complete rotation on its axis every day, which is 24 hours, and that rotation is itself of 360 degrees. Therefore, we can infer that 360 degrees equals 24 hours. So now, since we know how many degrees gives us 24 hours, let's find out how many degrees will give us 1 hour. So using the first equation, we have 24 hours equals to 360 degrees, so 1 hour will be equals to what? And solving this equation will give us 15 degrees. So therefore, 15 degrees is equals to 1 hour. So we know what the time equivalent of 360 degrees and 15 degrees is, but 1 degree is equals to what? So from the last equation we proved, we know that 15 degrees equals to 1 hour, and 1 hour is the same as 60 minutes. So writing it out will give us, now that we have proved all three key formulas, we can start solving questions with ease. The time in town X on longitude 15 degrees east is 4 p.m. What will be the time in town Y on longitude 15 degrees west? Now, for longitude questions, we need to list out our parameters. So let's draw two lines to indicate the longitude of the different towns. In town X, the time is 4 p.m., while the time in town Y is our unknown. So in exam, you can represent it like this, but without the earth in the background. You can just draw the two lines and write the towns and times the way I did. So now both of the places are located in different hemispheres. So that means the principle we're going to make use of is addition. Now that we know the longitude difference is 30 degrees because we added 15 and 15, converting this to time, we need to recall those three key formulas I told you of earlier. You can use any of these three formulas to get the final answer, but if you're able to pick the best one, it makes your work faster. And there will be cases where you may even need to use two of the formulas when we want to get time in hours and minutes. But for this question, I think the second equation will be perfect, as 30 degrees is closer to 15 than 360 degrees. So from equation 2, 15 degrees equals to 1 hour, so 30 degrees will be equals to 2 hours. But 2 hours is not our answer. Remember, we are looking for the time in town Y and not the time difference. This is where east and west from our definition of the international dateline come into play. So first of all, we need to determine what direction we are moving in. We can decipher this by looking at the direction of the unknown. So if I draw an arrow, it will point to the west. Remember that if someone goes west, they lose a day, which is basically subtraction. To get our final answer, all we need to do is subtract our longitude difference that we've converted to time difference, which is 2 hours, from the time that we know. And if we do that, we have 2 p.m. as the final answer. So our final answer is option B, 2 p.m. and not a.m. When subtracting and adding time, it's not always as straightforward as one we just did. So let me give you some examples before we move on to the next question. Imagining the face of an analog clock would be very helpful when calculating time accurately. Things are usually straightforward until you have to move past 12. This final step in the calculation highlights a key aspect of time differences. Knowing the difference in hours between two countries allows you to determine the time in one country based on the other. It's similar to the scenario I shared earlier before we started calculating. You may have heard your parents say things like, "We are 5 hours ahead of this country," or "This country is 6 hours behind us." So now let's quickly do these questions together. 4 p.m. minus 2 hours. This is the one we just did previously. And in this case, it's simple maths. 4 minus 2, and that's 2 p.m. to be specific. 2 p.m. minus 2 hours. Normally 2 minus 2 should be 0, but in this case, we are moving from 2 p.m. backwards by 2 steps, which is minus 2 hours. So that will be 1, 2, and that will give us 12 p.m. and this will be 12 noon. 11 a.m. plus 4 hours. Normally 11 plus 4 would be 15, which would have been correct if we were using 24-hour time. But in 12-hour time, we just need to move 4 spaces forward from 11. 1, 2, 3, 4. And that would be 3 p.m. The a.m. changed to p.m. because we moved past 12. So we moved from 11 a.m. to 3 p.m. So we are crossing over from morning to afternoon. Now the last one, 1 a.m. minus 3 hours. Now I want you to attempt this question. I believe you got your answer, 10 p.m. All you have to do is count 3 spaces backwards from 1 a.m. 1, 2, 3, and you get 10 p.m. And since we move past 12 a.m. again, the a.m. will now change to p.m. So we move from morning to evening. Now we can go back to our longitude questions. What will be the time in Sao Luís, Brazil, longitude 45 degrees west, when it is noon in London, longitude 0? Listen out our parameters. As we can see here, it's noon in London, which is telling us that the time is 12 p.m. So one place is located in the west while the other is located on the Greenwich Meridian. Now let's shorten Greenwich Meridian to GM. So the principle that relates to this question will be addition or subtraction. In this case, we are going to keep things simple by just adding the same way we did in the last video when we are dealing with the equator. Now converting this to time, we need to recall those 3 key formulas. Since we already have our change in longitude as 45 degrees, the 3 key formulas I told you to never forget. For this question, I also think equation 2 is the best. So now 15 degrees will be equals to 1 hour, so 45 degrees equals to 3 hours. And 3 hours is not our final answer. Remember, we are looking for the time in Brazil. So if I draw an arrow from London to Brazil where the unknown is, it should point to the west. And remember that if somebody goes west, they lose a day, which means subtraction. To get our final answer, all we have to do is subtract our longitude difference from the time that we know. As we did before, counting backwards from 12 will give us 9 a.m. a.m. and not p.m. as we are moving past 12, from 12 noon, as in 12 in the afternoon, to morning. So we just calculated the answer as 9 a.m. Moving on to the next question. The longitude that joins longitude 180 degrees at the opposite side of the globe to form a great circle is, if you've been paying attention from the beginning of the video, you should know the answer to this question, as I have already mentioned this earlier when explaining great circles. I made 2 important statements then, that a single line of longitude is only half of a great circle, and any pair of opposite lines of longitude forms a great circle because they connect the North Pole and the South Pole. I gave you examples as well, and that is the answer to this question. Longitude 0 degrees and longitude 180 degrees are opposite lines of longitude, and that makes this answer option A. So let's explain by illustrating. Let's say we are looking at the Earth from the front and the back. Now I know that the back view is just the Earth upside down, but please ignore and imagine with me, please. Now let's indicate the Greenwich Meridian, which is longitude 0. Now the opposite longitude would be us moving to the exact same location on the back of the Earth and draw another line to connect with longitude 0. And that line will be longitude 180 degrees, which is the approximate longitude of the international date line. Both lines meet at the North and South Pole, and these lines together will form a great circle that will divide the Earth into equal halves. In the 2 pictures above, the lines may not appear to be centered on the Earth, and that's because this diagram of the Earth itself is rotated. But rest assured, the 2 lines are positioned at the Earth center as shown in the image below. This alignment explains why moving from longitude 0 degrees to the opposite longitude brings us to 180 degrees, which represents half of 360, the total number of degrees of a full rotation of the Earth. Towns X and Y are situated on the equator. If town X is on the Greenwich meridian and town Y is on longitude 45 degrees east, what will be the time in town Y if the time at town X is 4 p.m.? So illustrating the given parameters, as you can see, they didn't give us the value for town X, but we know that the Greenwich meridian is on longitude 0 degrees, which I've written there. Now, since we are dealing with a place on the equator, we're going to be using the following principle. Now, let's solve the question. As we did before, we're going to add the longitude, which gives us 45 degrees. Recalling those key formulas from earlier, using equation 2, we get 3 hours when converting our change in longitude to time, and 3 hours is not our final answer. So if I draw a line from town X to the unknown on town Y, it will point to the east. Remember that if someone goes to the east, they gain a day, which is addition. To get our final answer, all we have to do is add our longitude difference, that is the 45 degrees we've converted to 3 hours, to the time that we know, and that gives us 7 p.m. Here, 4 p.m. plus 3 hours gives us 7 p.m. So here the addition follows like the normal routes. Our final answer, option D, 7 p.m. The degree of longitude through which the Earth spins within 3 hours is, I know we haven't solved any question in this format, but I want you to attempt this question on your own. If you were able to do this question on your own, good job. And if you got confused, no problem. Now let's solve it together. The question is basically asking us for the equivalent of 3 hours. Now let's bring back our 3 key formulas. In this case, we will still use equation 2. So if 15 degrees equals to 1 hour, then 3 hours will be equals to what? 45 degrees. I know some people have been thinking, how come it's only equation 2 we've been using? You can use the other 2 as well. For this question, you can use equation 1. But equation 3 would be a waste of time for an objective question, as you have to convert 3 hours to minutes first and then use it to calculate the longitude. But let's try solving it using equation 1 so that you can see. The answer is still the same, but using equation 2 will be simpler in my opinion. And now our final answer, bringing back the options, would be option C. Now you can see that this is a very simple question. What is the time in Accra at longitude 0 degrees when the local time at longitude 45 degrees is 12 noon? Now this question was asked in 2018 and also 2021 objectives, so this question was repeated. So since one place is located in the west, while the other is located on the Greenwich meridian, longitude 0 degrees, the principle relating to this question will be addition or subtraction. Now, after adding, we get 45 degrees as our longitude difference. Converting this to time, we need to remember the key formulas. Using equation 2 again, we get 3 hours, which is not our final answer. So if I draw an arrow from Accra to longitude 45 degrees, it would point to the east. Remember that if someone goes to the east, they gain a day, which is addition. So to get our final answer, all we need to do is add our longitude difference. That is the time 45 degrees converted to 3 hours to the 12 p.m. that we have. Now imagine the face of our analog clock. From 12 p.m. we move 3 spaces forward, and that gives us 3 p.m. So the answer is option A. Two opposite longitudes form. With all we've done so far, you should be able to answer this question. A great circle. And the example I gave was longitude 0 degrees and longitude 180 degrees. How many standard time zones will a country with a longitudinal extent of 150 degrees have? Okay, before solving this question, you need to understand the concept of standard time. Standard time is the official time adopted by a country based on the central meridian. Each standard time zone spans 15 degrees longitude, which corresponds to 1 hour, and the world is divided into 24 time zones. So it makes sense that the Earth is divided into 24 time zones, because if each time zone is 1 hour and we have 24 hours, so 1 hour is 15 degrees longitude, then 24 time zones will now be 24 times 15, which gives us 360 degrees, which corresponds to the key equations that we've been using to calculate longitude questions. So now let me illustrate this to make my point clearer. So let's say that this is a country and we have these lines of longitude. Now this country is crossed by 6 lines of longitude, as you can count now, each spanning 15 degrees. So in total, we can say that this country spans 90 degrees longitude, 15 times 6. But if each line will cause a 1 hour change, that will lead to confusion when moving from one part of the country to another, because they will not know which time they should use. So instead, the country will adopt the time of the central longitude or meridian. So if we name these longitudes, in this case, the country will take the time of longitude 75 degrees, its central meridian. Well, that's by the way. Now let's get back to the question. So remember that each time zone spans 15 degrees. So therefore, 115 degrees will be equals to 10 time zones, making option A our final answer. I know that before we've been used to seeing 15 degrees as equals to 1 hour, but remember when defining standard time, I said that each time zone represents a change in 1 hour and each time zone spans 15 degrees. So at the end of the day, 15 degrees equals to 1 hour, which also equals to one time zone. So everything is still the same. Town A is located on longitude 15 degrees east, while town B is located on longitude 45 degrees east. If the local time in town A is 6 a.m., what will be the local time in town B? Illustrating our parameters, now we are going to use a new principle. When the places are located on the same hemisphere, as you can see, both of them are located in the east. In this case, we are going to subtract. Now we're going to subtract the longitude, which gives us 30 degrees. Recalling those three key formulas from earlier, from equation 2, 15 degrees equals to 1 hour, so 30 degrees will be equals to 2 hours. And 2 hours is not our final answer, as you almost know at this point. If I draw an arrow from town A to our unknown, which is located on town B, it would point to the east. And remember that if a person goes east, they gain a day, which is addition. To get our final answer, all we need to do is add our longitude difference. That's the 30 degrees longitude that we converted to 2 hours, which is now our time difference. We can say it like that, to the time that we already know, 6 a.m. So 6 a.m. plus 2 hours gives us 8 a.m. So when picking our answer, we need to be careful. After calculating and getting the right answer, the examiners will not get you at the final stage. The answer is 8 a.m., not p.m. How many standard time zones will a country with a longitudinal extent of 165 degrees have? So now you should be able to answer this question without breaking a sweat. So I hope you all got 11 as your answer. In case anyone didn't get it, let's look at the calculations. So if 15 degrees is equals to one time zone, 165 degrees will now be equals to what? So we divide it by 15 and that gives us 11 time zones. Remember that each time zone spans the 15 degree longitude, don't forget that, and which is also equals to 1 hour as well. The longitude which almost bisects Africa into equal halves, east and west, is longitude. Now this question is not one that can be solved by calculation, so let's try to deduce the answer. They expect you to know the latitudes and longitudes that Africa is located between. After all, this is WAEC, West African Examination Council. According to the required textbook, that is Essential Geography for Senior Secondary School, Africa is located between latitudes 37 degrees north to 35 degrees south and longitudes 17 degrees west to 51 degrees east. So now let's show the longitudes on the outline of Africa, starting with the Greenwich Meridian, which is on longitude 0 degrees. Recall the illustration I gave you when explaining standard time, that each time zone spans 15-degree longitude. And now these are the longitudes that cross Africa, and as you can see, the time interval or the interval between each number is 15 degrees, representing one time zone. So Africa is located between 17 degrees west, 51 degrees east. Now you can look at the options and eliminate them. We can take out options B and D first because they don't even pass through Africa, not to talk of bisecting it. Option C will also be eliminated because I'm sure you can see its position. And as you can tell, that's not going to divide Africa into equal halves. And that leaves us with option A, which will be the correct answer. And placing it on Africa, we see how we divide the continent into equal halves, east and west. What will be the time at the Greenwich Meridian when it is 12 noon at longitude 60 degrees east? At this point, we're almost done with solving objective calculations on longitude, so you should be attempting this question on your own now. So now let's illustrate our given parameters. As you can see, they expect you to know that the Greenwich Meridian is on longitude 0. Since we are dealing with a place on the equator, we'll be using the following principle: add or subtract. Now let's solve our question. As usual, for the equator question, we either add or subtract. The answer will still be the same. So we get 60 degrees. Recalling our key formulas and using equation 2, we get 4 hours. So if I draw an arrow from longitude 60 degrees east, it will point to the Greenwich Meridian on longitude 0 degrees, which is in the west. Remember that if someone goes to the west, they lose a day, which is subtraction. So to get a final answer, all we need to do is subtract our time difference, that's 4 hours, from the time we're given, and that gives us 8 a.m. And to get this, all we need to do was count backwards from 12 a.m. Now, moving from 12 p.m. backwards by 4 hours will give you a.m. and not p.m. Since we are moving past 12, so we're moving from 12 noon, so that's 12 in the afternoon, back to morning. So our final answer is option C, 8 a.m. If the local time in Accra, Ghana, longitude 0 degrees is 2 p.m., what is the longitudinal location of town K, whose local time is 5:20 p.m.? As you can see, this question is from NECO objective. So instantly you can see this question is different from the ones we solved earlier, because instead of us looking for time, we are looking for the value of the longitude. Additionally, the time provided here is not a straightforward number, unlike the solid values you've been accustomed to working with. So you can try this question. It will be very impressive if you get the answer. Now let's solve it together, illustrating our parameters. Firstly, the principle we're going to be making use of is addition or subtraction, since we're dealing with a place on the Greenwich meridian. First, we find the longitude difference, but as you can see, we can't get a value because of the unknown longitude of town K. So looking at the questions, we have two unknown values. I've represented the unknown longitude the question asks for as K degrees, while the change in longitude is represented by delta L. The delta sign means change, in case you didn't know. Out of these two unknowns, we can get delta L first. In the questions we've solved earlier, we always had a change in longitude, which we converted to hours to get our time, to get the time as our final answer. So now we are going to do the steps in reverse to get the time and convert it back to degrees. Now let's draw an arrow from Accra, Ghana, pointing to our unknown. As you can see, the arrow points towards the east, and that means addition, since a person going east gains a day. So our equation will look like this. 2 p.m. plus change in L will be equals to 5:20 p.m. The place where the arrow is pointing to would have been the time we're looking for in the previous question, and that is why the equation is arranged like this. So we're arranging the equation by bringing the like terms to one side to get the value for delta L. We have 3:20 p.m. as our change in longitude converted to time. Since the subtraction is pretty straightforward, you can do it simply like this. But for subtraction of time, I would advise you to arrange this in the way you were taught when you were doing addition and subtraction in your nursery or primary school, like this: column subtraction or vertical subtraction. You can ignore the PM at this point. This clearly shows that it's a straightforward subtraction. But let's say we're given something a bit more tricky, like this. Now, I know that a lot of you here can probably solve this with your eyes closed, but still I'm going to solve a scenario like this because you'll be surprised at how people forget the simplest things under examination tension, and it can be very painful. So I'm sure you can clearly see the difference between these two calculations. Now we know that we cannot subtract 35 from 0, so we are going to have to borrow 1 from 5, and the time you are seeing is in hours and minutes. So if we borrow 1 from 5, we're not going to be borrowing 10 as you normally would when you're carrying over. Instead, we are borrowing 1 hour, which is equivalent to 60 minutes. Now it will be easier to subtract. 60 minus 35 equals 25, and 4 minus 2 equals 2. And now we have a final answer of 225, 2 hours and 25 minutes. So now that we're done with this, let's get back to the question. We have our change in longitude as 320, which you need to convert to degrees so that we can get our final answer. At this stage, you might be a little confused on how to convert this back to degrees, but if you break it down into 3 hours and 20 minutes, it will be easier. So we convert them separately and then add it together. Bringing back our 3 key formulas. Solving for 3 hours, we get 45 degrees, and for 20 minutes, we get 5 degrees. So the change in longitude in degrees is 50 degrees. So 3 hours 20 minutes is equals to 50 degrees, and this is not our final answer, mind you. This is the value for the change in longitude, but we are looking for the value of the longitude town K is on. Now we've gotten a change in longitude already, so let's put it into the equation above. Solving for K, as you can already see, is 50 degrees. So if you stopped at the change in longitude and pick 50 degrees as the final answer, you would have gotten the answer, and that is only because the other town is on the Greenwich meridian, longitude 0 degrees. Hence, it didn't affect the value. But if the other longitude was 15 degrees, then that person wouldn't have been so lucky. And if this was a theory question, you still have to complete it since each step has its own respective marks. So now the final step, is it going to be 50 degrees east or 50 degrees west? And this is where our illustration is useful. As you can see, our arrow is pointing to the unknown, which is in the east. So our final answer will be 50 degrees east. Now all that's left to do is pick the correct answer from the options. If you manage to get the answer, then hats off to you. But if you got a bit confused, you can always reword the solution. Now we move on to the last objective question. Which of the following longitudes does Nigeria use for our standard time? This question is under NECO question and it's really testing whether you know your facts. NECO is an examination body in Nigeria, so you need to know some things about Nigeria, like its position and the latitude and longitude it's located between. So the answer to this question, as mentioned in your recommended textbook, Essential Geography for Senior Secondary School, is 15 degrees east. And this was stated there when they were explaining the concept of standard time. Nigeria uses 15 degrees east as standard time, which is 1 hour ahead of the GMT, Greenwich Mean Time. So remember in the WAEC question we solved earlier that there was a question on which longitude bisects Africa. So they expect you to know these facts when writing exams. Now let's move on to the theory questions. If you are going to see any calculation question in your theory, it's most likely going to be on longitude. The last time there was a theory question on latitude calculation was in 2009. So without wasting any more time, let's move on to some theory questions from WAEC and NECO. I would like for you to attempt all these questions before I solve them for you, since you should already be masters on longitude calculations with all the objective questions we've solved. If you've watched the previous video on calculations on latitude, remember that the part A of this question was the only latitude theory question that we solved there in the last 10 years. But now our focus is on the C part of this question. A football match for 5:45 p.m. local time on Saturday in Onitsha, Nigeria, longitude 7 degrees east. Calculate the local time football fans in Mambula, Sierra Leone on longitude 13 degrees west can tune their radio set for the commentary. Now let's solve this question the way you'll be expected to write it on an exam paper, starting with illustrating the parameters. So I'm not going to be adding the picture of the earth because I mentioned at the beginning when solving that I only added it to make the solutions more colorful. Now let's put in the other things. So we can clearly see where everything is. Make sure not to mix up the positions of the longitudes. If you are confused, you can draw a small cardinal point to help you orient yourself. East is to the right, while west is to the left. Now let's mention the principle we'll be using. Since both the places are located in different hemispheres, that means we're going to add. So now that we've gotten a change in longitude by adding 13 and 7 degrees equals 20 degrees, the next thing to do is convert the longitude difference to time. In your theory, you don't need to write out all three key formulas as we've been doing earlier. Just the relevant one is enough for us. In this case, that would be 1 degrees to 4 minutes. Now, I know that some people may be confused at my equation choice, but trust me, it's the most straightforward one. Now, the equivalent of 20 degrees will be 80 minutes, 20 times 4. If I had used 15 degrees equals to 1 hour, we would get a fraction, and from there things would have gotten a bit more confusing. Remember that 1 hour is equals to 60 minutes, and so 80 minutes will be 1 hour with 20 minutes left over. But as you must know at this point, this is not a final answer. Drawing an arrow pointing to our unknown, we see that it points to the west, which means subtraction, since a person going west loses a whole day. So that means we are going to subtract our time difference, 1 hour 20 minutes, from the time that we already know, which will give us our final answer as 4:25 p.m. 1 hour 20 minutes is the same as 120, so you can carry out the subtraction as usual. If you're a bit confused, you can do so in column of vertical subtraction, which is what we demonstrated last time, as this will make subtracting in time easier. So the local football fans in Mambula, Sierra Leone, which is on longitude 13 degrees west, can tune their radio set for the commentary at 4:25 p.m. on Saturday, which is around 1 hour earlier on that same day. So in your theory, there is no need to draw this again and put the final answer in. The one you did at the beginning is sufficient. If two towns A and B are located on different time zones, the time in town A is 9 a.m. while the time in town B is 6 p.m. on the same day. Calculate the longitude of town B if the longitude of town A is 30 degrees west. So you should be able to do question A, as we've already discussed this earlier in the video. Now, according to question B, we are looking for the value of the longitude. So illustrating our parameters. Since we don't know the longitude of town B, the placement of our location is uncertain. We don't know whether we're supposed to place it to maybe the left of town A or the right of town A. And we cannot also determine the principal since we don't know if town B is in the same hemisphere as town A or in a different hemisphere, as wasn't stated in the question. I know at this point you might be feeling worried since it's looking like we don't have any values that can help us, but don't worry, let's solve this together. Since we have the time for both of the towns, we can find the time difference and then convert this to degrees, which would be our longitude difference. And this will give us 9 hours. And you can't do this type of subtraction straight because if you even try, you get 3 hours, which is wrong because you can't be subtracting AM and PM together. That's what will give you the false perception of 3 hours. The actual answer, or the actual time difference between 9 AM to 6 PM, is 9 hours. And if you remember the face of the analog clock that I told you to always reference, moving from 9 AM to 6 PM in a clockwise direction will give us 9 hours. Let's count it together. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 hours. So now we need to convert 9 hours to degrees to get the difference in longitude between the two towns. And the key formula that will help us in this case is 1 hour is equals to 15 degrees. So the value of 9 hours in degrees will be 135 degrees, which is not our final answer. Now that we have the longitude difference, we need to know whether we are subtracting or adding the longitude of town A, which is 30 degrees, to it. And for that, we need to know whether town B is in the east or the west. But because of our time difference, it will be easy for us to infer this. So the time in town A is 9 AM, while the time in town B is 6 PM. So we can say that town B is 9 hours ahead of town A. So while it's morning in town A, it's already evening in town B. If town B is ahead of town A, that means that town B is east of town A, because people going towards the east gain. This means that both towns are in different hemispheres, east and west. So now we know the principle we're going to use: addition. So writing out our equation, we have this. The longitude difference will now be equals to the longitude of town A plus the longitude of town B. And so from my equation above, we know that town B is our unknown. So let's put in all the values we have to get the final answer. 135 degrees equals to 30 degrees plus our unknown, that's longitude of town B. And then if you collect like terms, 135 degrees minus 30 degrees will give us 105 degrees east, which is our final answer. If the time at longitude 100 degrees east was 5 AM on Monday, 11th April 2011, what is I, the time at longitude 10 degrees west, II, the day at longitude 10 degrees west, and III, the date at longitude 10 degrees west? Now, don't mind the examiners trying to scare you in question C by making it look as if they're asking for plenty things. There's nothing special in calculating the day and the date. In fact, they are not difficult to get. Illustrating our parameters, and the principle we're going to be using is addition, since we're looking at two places located in different hemispheres, east and west. Now we have our longitude difference, and converting this to time, you need to remember our key formula, and the one we're going to be using is 1 degree is equals to 4 minutes. And I picked this because 110 divided by 15 degrees will give us a whole number. So the time equivalent of 110 degrees is 440 minutes. And since we know that 60 minutes is equals to 1 hour, so from 40 minutes we can get 7 hours with 20 minutes left over. Now let's also get the time difference using 15 degrees equals to 1 hour. And I'll let you compare which one you think is easier, so you can pick the one you understand better in case of exams. So 110 divided by 15 degrees will give us 7 whole number 1/3. And as you can clearly see, this is not a whole number, but we can break it down as 7 hours and 1/3 of an hour. Converting the fraction to minutes, we already know that 1 hour is equals to 60 minutes, and off means multiplication, so that will give us 1/3 times 60, which gives us 20 minutes. So 1/3 of an hour is 20 minutes. And the total time difference is 7 hours, 20 minutes. Personally, I feel that the first one is easier, but at the end of the day, it all depends on you. Whichever one you feel you can understand better is the one you can refer to when doing your exams. Now we can rewrite our time difference as 720. Now to our final answer, I'll draw an arrow pointing to the unknown, which is in the west, and that means that we're going to subtract. So our final answer will be 5 AM minus 720. And if you're able to do subtraction straight away, perfect. But if you're a bit confused, you can break it down and subtract. First, we subtract 7 hours from 5 AM, and that will give us 10 PM. In cases like this, remember the face of your analog clock. We went from 5 in the morning to 10 PM in the evening of the previous day by moving 7 hours back. So now I'm sure you know how the date will change. But we are not done yet. We still have to subtract 20 minutes from 10 PM to get the final time on longitude 10 degrees west. And that will be 10 PM minus 20 minutes, which gives us 9:40 PM the previous day. And so we'll have our final time as 9:40 p.m. the previous day. Now we have everything we need to answer our sub questions. We already have the answer to I, 9:40 p.m. the previous day, and therefore the day at longitude 10 degrees west will be the day before Monday, which is Sunday. And the answer to II will now be Sunday, 10th of April 2011. The main point of this question was you understand that subtracting the time difference will give you a time in the previous day. And now moving to the last question for this calculation in longitude video. A friendly football match between Nigeria and Japan took place at 3 a.m. on Saturday, 25th July 2020 in Rio de Janeiro, 22 degrees south, 43 degrees west, Brazil. Calculate the time and day in which the listeners and viewers can tune in to hear or view the radio or television commentaries of the match in Tokyo, 35 degrees north, 140 degrees east in Japan. Now this question is from NECO GCE and they are trying to put you up by making the question too wordy. So let's illustrate the parameters so that we can properly understand this question. So now this question is not different from the previous one we did. I have underlined the key points of this sentence, but there's something unique about this question that can cause a large number of students to fail this question from the very beginning. The question gave you both the latitudes and longitudes of the two places involved, but they asked you to calculate the time and day and not the distance between the two places involved. So that means that the latitudes they gave you, you don't need them for anything in your calculations. In fact, you can cross it out from the question so that you don't mistakenly use it to calculate, so that you won't be that person who confidently uses the value for latitude to calculate time in your exam. And when you now get out of the exam, you now hear your friends talking about how they didn't make that mistake. At this point, you guys should be able to differentiate latitude from longitude. Longitude is the measurement of a location east or west of the Greenwich meridian. So anything east or west is longitude, as we've defined this at the beginning of the video. Now, since both places are on different longitudes, we are going to use the principle of addition. We have our longitude difference as 183 degrees. The next thing we need to do is convert longitude difference to time. And I'll be using the equation 1 degree is equals to 4 minutes. And so 183 degrees will be equals to 732 minutes. And from 732 minutes, we get 12 hours with 12 minutes left over. Drawing an arrow pointing to the unknown, we see that it points to the east, which means addition. So now to get the final time, we need to add our time difference to 3 a.m. and that will be 3:12 p.m. the same day. If you move 12 spaces forward on your analog clock from 3 a.m., you'll be back to 3, but this time is 3 p.m. and you just add a 12 minutes, making it 3:12 p.m. the same day, since you only move from morning to afternoon. Or another way you can add the time difference is by doing it directly. So you add them together, that's 3 a.m. plus 12:12 to give you 15:12 in 24-hour time. And then to convert or to get the normal 12-hour time equivalent, you just subtract 12 hours from the 15:12 and that will give you 3:12 p.m. the same answer. So whichever one you prefer. So the time in Tokyo is 3:12 p.m. on Saturday, 25th of July 2020. Listeners and viewers in Tokyo can tune in at this time to hear or view the match commentary. So the time in Tokyo is 3:12 p.m. on Saturday, 25th July 2020, and at this time, the listeners and viewers can tune in to hear the commentary of the match. And that brings us to the end of our video. I know some of these calculations were not straightforward, but make sure you rewatch any of the question solutions that you didn't quite understand. These are the questions you won't be able to escape in objective, and if you're lucky enough, you might see it in theory. And since you've watched the part 1 and 2 of these videos, there will be a bonus for you. If you have any topics you want me to make videos on, then type them out in the comment sections. But now I'm going to be focusing on NECO solutions. Make sure to like, share, and subscribe. Thank you.